All right, hello and welcome. First, let me talk about what Munro is. Munro Associates is an engineering consulting firm with the design-first approach. We reimage our clients' products and processes to unlock better business outcomes, driving down costs while improving efficiency and quality. At the core of our work is lean design, our proprietary methodology that optimizes design efficiency and consistently delivers exceptional ROI for our clients. So, our podcast is a little different. For years, you have seen us at Monroe Live take apart cars, tearing down technology, and figure out how things are really made. But today, we're doing something a little different. So pull up a chair, grab a cup of coffee, and join us for the first ever Munro Fireside Series, or whatever we're going to call it later on. But for now, we'll call it Fireside Series. This is where we get to have the in-depth, no-holds-barred conversations with the experts that live and breathe this stuff every day. So today, we're going to talk about the heartbeat of the EVs, the battery. I have three Munro experts here with us to talk about this, hopefully pull back the curtains and really see what's going on with the battery technology. My name is Mike Kaysen. I will be your host, and let's introduce our experts. John.
Okay. Thank you, Mike. Well, hello, listening audience. My name is John Wessendorf. I am a lead engineer here at Munro Associates. I've been here about a year and a half. And in the battery world, I have about 33 years of high-value manufacturing around the world.
And I'm Paul Turnbull. My main focus here has been motors. But of course, motors don't work without batteries. And so my whole career, I've been working with batteries and been an avid watcher of the battery industry.
And I'm Matthew Lawrence. I'm the baby of the group. I have about a decade of work in battery design, battery systems, and some simulation work in the past as well.
And Matt, you actually have something unique. You've actually built your own electric motorcycle.
Yeah, I've built a couple electric motorcycles. My own GSXR converted to electric. You guys all saw that. And I did a 1929 Indian and a 1929 Henderson, converted those with my mentor to electric as well.
Very good.
Maybe one day I'll bring it in.
Just throw it off. All right, so let's first start with Munro. We've done a lot of tear down the battery packs, right? And we've seen a lot of technology, not just I think in automotive, but also in other consumer products. I'm curious, what have you guys seen, if anything, that's really stood out, or maybe it's really bad or really good, and maybe where you think that technology is going?
Well, for years we talked about, hey, wouldn't it be a good idea to skip module build and go directly from cell to pack? Well, I actually saw that here late last year, early this year with a teardown that the team did, with myself included on the BYD Shark. And those were actually miniaturized blade cells. And you could tell they went by design directly from the factory floor at cell level into the pack at pack level. It's a structural design, which I think a lot of the industry is going these days, but it was a nice package. That's from my standpoint.
And what does that get you? I mean, is that a cost reduction, or is that
It is a cost reduction, yes.
Yeah, simplicity. But there is a cost to that, and that's not going to be the right thing for every application. And the penalty for doing that is you lose flexibility. So you're going directly from cell to pack means that you lose that module perspective. So if you have a module
serviceability,
then you get serviceability and you get a kind of flexibility. So you can have multiple different packs with the same module. So if your business case is such that you need to have a variety of different pack voltages, pack energy densities or energy levels, then going with a common module may be something that works better for that business case. And so that, that's the trade-off of going directly to from cell to pack. Although I think that in the case of BYD, they're a little bit unique because they are the cell manufacturer. And so for them, they have much less of a trade-off because the cell is the common item across all of their designs.
Yeah, they're clearly vertically integrated, as Paul just mentioned. So it's rather easy for them to go directly from their factory floor there to at cell level to the pack level, from their factory floor there to put everything together. And you're right. The serviceability, it's not really there. If something goes wrong with the pack, well, the whole pack has to go bye in the trash heap for recycling or whatever.
And that's this case also. The other competitor, of course, that's doing that is Tesla. Yes. Tesla was originally kind of going with these large modules, and like 4 modules in a pack, but it's really the structural pack that the cells are directly loaded into. And they're able to do that again because of the vertical integration. The cell becomes the common unit from one pack to another.
Does that give you like a packaging challenge, Phil, because you're going to this pack instead of a cell, or it does not matter?
It's all part of the upfront design, so it's designed in.
Yeah. Okay.
So Matt, what have you seen that's been unique in your eyes?
I guess one of the first videos was that I watched here was the same side interconnects. I always thought like, oh, you had to do battery welding or laser welding or anything on opposite sides, but then I realized you can do welding on the edge of the can. So that, in my mind, blew open like what you could do also with cooling. You could have it partially submerged in dielectric fluid, or not dielectric, cooling fluid. You could also have a different style of cooling planes or cooling channels and things like that. It just opened up because now you have more space and you don't have to worry about the electrical issues of the interconnects getting in the way.
That is one of the things that we at Monroe look for in an assembly process. So anytime you have an assembly operation that involves just flipping the thing over so that you can work on the opposite side, that flipping operation is a non-value add. We look for ways to get rid of that. Yeah. So anytime we see non-value add operations in an assembly process, so we're design led. We're focused on design, but the idea is make the design conducive to the manufacturing process. Yeah. And so that's looking for those things where you can eliminate the flipping operation and work on all one side. That's ideal.
Yeah, I thought it was really clever.
I do think that the CATL cells, the prismatic cells, lend themselves to that because everything that's on the top surface. Mm-hmm. So if you're not a battery cell manufacturer and you're integrating the cells into modules or packs, then choosing a cell that is conducive to that sort of operation, single-sided, so you don't have to flip the thing over.
But that really does lead to you need enough surface area on the can to do that operation as well. So which the 4680s have a broad negative on the top of that can.
So we recently took apart a Skywell ET5. I think that was the model number earlier this year, and tore it right down to the last nut and bolt, including the battery pack. Those were pouch cells. Shifting the conversation from cans to or cylindrical to pouch. Those two had tabs, anode and cathode on the top side, and individual modules gang together to form the entire battery pack. So all that welding was topside work too. So that was value add on their factory floor. Although the particular pack itself pretty much looked like it was put together in the garage, if I have to be brutally honest. But it was functional and it got good reviews. The materials were simple compared to some of the other stuff that we pull apart here. If you look at that on our showroom floor compared to the other versions of packs we have from the different auto manufacturers, it looks a little bit different than those.
Yeah, I have a bit of a love-hate relationship with pouch cells.
Yeah. The thing though with the pouch cells though is you can get more energy density in the package compared to the cylindrical and the prismatic. However, you need an exoskeleton around that package because really it's a Pop-Tart with terminals on it, and it's a little flimsy, so you have to structurally contain it. Unlike the prismatic, which is a can, as I think a lot of the audience knows that's going to listen to this, and the cylindrical too, which is in a can.
Okay, good. So let's go to the chemistry of the batteries, right? So LFP, or lithium ion phosphate, seems to be becoming the dominant player in this field. Do you want to explain why that might be, and why would they go to that LFP compared to high nickel?
Cost is the driver there. It has good operating temperature, has thermally it handles itself well under load. Although the energy density isn't where it needs to be relative to some of the other chemistries. Those are my key takeaways.
Yeah, there's always been this trade-off between energy density and cost.
Yep.
And particularly between those two, the NMC chemistry, which has cobalt in it, which has a cost issue and a supply chain security issue.
That's a big one.
LFP, where you have iron and phosphate, they're relatively less expensive and more available.
Less domination, or less dependent on outside.
But you're paying a penalty in weight and energy density when you go that way. And boy, right now here, August 2025, we sort of stand at the precipice of what could be a shift in energy density and chemistry. But boy, I don't know what your experience is. But
what do you mean exactly, though?
Well,
when you say precipice,
we have this. The battery suppliers have become very adept at continually promising something new on the horizon. And so we here at Monroe have gotten a little jaded with the perpetual promices of something new on the horizon.
Well, let me add to that.
Liar, battery
Yeah, well, let me add to
supplier.
that. So, because GM last week announced that they are doing what they call LMR, which is lithium manganese rich, that promises lower cost and be more affordable materials and simpler prismatic design.
Well, so I like this kind of thing because they're not just announcing that they have this chemistry, but they're announcing investment. And so my general rule of thumb is to follow the money. So when I don't really pay any attention to the promises or the lab results, I wait until I see investment in plants. So real significant investment and volume manufacturing. So when you see real volume manufacturing happening, that's the technology that I start paying attention to. And these days, it's all about cost. So energy density and some of the earlier promises about, hitting this,
500 watt hours.
500 watt hours per kilogram, that sort of thing. That seems to have taken a back seat from what I've seen in where the real money is being spent. So the magnesium-rich chemistry offers an opportunity for a little bit lower cost. And so we're seeing real money go there. And sodium ion, we're seeing real money being spent tooling up plants to produce these, and all for the promise of lower cost.
So Paul's right. I also follow the money. If I see money being invested in a facility to build battery cells, then my eyes tend to gravitate towards that. I've been doing this for 30 plus years, and LMR has been on the conversational landscape for a long time. And it's nice to see, along with solid state. I guess we'll talk about solid state here in a little bit, but it's nice to see finally a lot of money being poured into a facility here in this state, actually. And even though they're in the pilot, actually they're in the pre-production / R&D phase currently. I don't think they plan on rolling out to a production scale until sometime in 2028. But at least they have a target date. They have a lot of money backing that current pre-production R&D activity, which is good to see. And you're right, Paul, sodium ion is starting to gain some traction out there here. And nice thing about those two chemistries is that they're readily available too. We don't have to rely on foreign supply chain.
Yeah, supply chain issues and supply chain security is a big deal.
But do you think that the LMR battery is going to do a dramatic reduction in cost, or do you think it's just going to be minimal?
That's hard to say.
Yeah, I mean,
We'll see. The promise is there for.
they say it's going to be a pretty big cost, right?
I mean, let's say you had a magic chemistry right now that you could do for 1/10 the cost of today's battery. If you have that as a manufacturer, you have no incentive right now to deliver batteries at 1/10 the price. You know, all your competition is still up at $100 per kilogram, or I'm sorry, $100 per kilowatt hour. And so if you can do 95, your price, say you do $10 per kilowatt hour,
that's some crazy
you're
margin.
still going to charge 95 and pocket the rest as profit. So I expect to see, and would be surprised to not see anything other than incremental changes. There has been continuous pressure, and the oversupply is adding to that pressure. So we're going to continue to see incremental reductions in prices, but I don't expect to see a dramatic, like halving of the prices out there.
And you guys mentioned solid state batteries. We can go on that a little bit there. It has become known as kind of the holy grail to some people. Why is that? And do you think solid state is the answer, or it might be the answer to the future?
It has significantly more energy density for one thing, but because it's not really at scale yet, far from it, it's extremely costly. There are companies out there that are producing this at different levels. But again, it's extremely expensive. It's very safe.
The one thing I heard was with the heat expansion. So let's say as the battery's working, the cell expands, and you'll get like a millimeter of expansion in the solid state. But if you have 100 of those cells, and then you have to account for 100 millimeters of change, I could be wrong. This could have been solved already or changed, but that's one of the things I heard.
No, you're right. It's still a challenge. I think it probably is still a challenge to some of those companies that are still, not still mass producing or producing them at some limited scale currently. But the thing, though, is it's an extremely safe chemistry. If it's truly a solid state, if it's a pseudo-solid state, then they're using a liquid / semi-solid electrolyte. Doesn't make it as safe. They're easier to produce for various reasons. There's also other companies out there trying to gain traction with we talked about lithium iron phosphate, but lithium manganese iron phosphate as well. And that's also an extremely good chemistry that's out there on the horizon if they can bring it to scale.
So there was another article from Nissan that said they partnered with a company called LiCAP, L-I-C-A-P, on solid-state battery production. Basically developing dry electrode manufacturing for solid-state batteries. Is this something that would help drive solid-state to be more...
Tesla do something like that with Maxwell?
I don't know that.
Because LiCAP sounds like it's a
I thought they bought Maxwell.
Yeah.
I can't remember. I know a little bit about LiCAP.
LiCAP, yeah.
You guys want to comment?
I don't.
You don't?
Yeah, I'm
Okay.
not familiar.
So this is a company that's out west in California. They've been around a while, and what they do is they supply mixing and coating equipment for the dry electrode process. And it's pretty cool. And the reason why I say it's pretty cool is that the industry itself is trying to shift away from the wet coating process. And why are they doing that? The reason why is because you have to use solvents, and it's a nasty process. And the equipment that's used after you coat, it goes into ovens, and the ovens are extremely long. I've been in factories where the ovens take up a significant amount of factory floor space, like a football field and a half long. It's incredible how long these things are. And it's all in case of, obviously, in a factory. And when you go to the dry, and
It's got to be energy intensive.
it just sucks the energy out to use it. And plus you have like NMP recovery process. You got to scrub your solvent and maybe reclaim it and put it back into your system. So it requires a lot of energy and a big footprint. The dry process eliminates that big drying activity. It takes powdered material and it dispenses it directly onto the substrate. Other people call it a collector. The anode and the copper or the aluminum as part of the anode and cathode separately. They'll dispense the powder directly onto that under compaction rollers. There's no drying. There's no solvent recovery system. You significantly, by order magnitude, reduce the overall footprint of what used to be a lot longer. And I did mention a football field long, a football and a half long. I'm not exaggerating it. You shrink it way down significantly. So
there's still a baking process to like adhere the.
No.
Okay.
No. It goes directly from mixing to the dry process, and then from there to calendaring and slitting.
And then how do you introduce the electrolyte?
Well, that comes further downstream.
Okay.
That has to be processed if you're either the anodes are wound or they're Z-folded for pouch. And then after they're in the container, either in the cylindrical can, a prismatic can, or the foil pouch, from there, after that, it gets filled with electrolyte.
This is a classic case of the manufacturing process driving the cost of the product, even more so than the materials in it. And so which is something that, we at Monroe have constantly been trying to push. And that's sort of been Sandy's original philosophy that we're trying to carry on here, where if we can simplify or eliminate parts of the manufacturing process to get the cost out of the product. And you do that by adjusting the design so that it can take advantage of these advances in the manufacturing process. It makes all the difference in the world. So that's where hopefully we'll see these advances in the cost of the batteries coming down. Again, though, it's been, we're a little bit jaded on the promises. So it's been really hard to crack those technical issues to get that kind of production process in place.
Exactly. Matt, we didn't hear you very well the first time you said it about the 3 types of liars.
Oh, liar, battery supplier.
Well, there's liars.
Damn liars.
Damn liars, battery suppliers.
Yeah.
Exactly, yes.
Which is,
that's true.
That's been a part of the business case for, battery suppliers has been keep the messaging out ahead of the technology. And it just has worn us down to the point where we're all now from Missouri, and we wanted them to show us.
Yeah, it's all good until the venture capitalists pull the funding, and then everybody loses their jobs and start another battery.
All right, so let's switch subjects here a little bit before we get too far. So there's a couple different architectures, right? We have a 400 volt and 800 volt plus architectures, right? It seems like every brand seems to be moving up to the 800 plus volts for faster charging, but yet Tesla seems to be stuck at the 400 volt, and they are able to obtain that same fast charging. Why is there a need to go to 800 volts for these other manufacturers? What is Tesla doing that others aren't?
Well, people's opinion on this is focused at the Ohm's law level. That, okay, I double the voltage,
The
and
high
then
times
my,
are,
my
yeah.
current goes down by half, and so all my wires get smaller and cheaper, and I'm just going to save huge amounts of money. The sad fact is that in a motor, if you want it to make the same torque, then you get exactly zero savings from increasing the voltage to 800 volts. The motor, because if you cut the current in half, now you need double the number of turns in the motor, because it's Ni, the number of turns, times the current that gives you the magnetic field that you need to make the torque.
So then why are these manufacturers going to 800 volts? Is it just a...
So 800 volts is not that, it's not a panacea. It's not a cure-all. There are some advantages and there are some disadvantages. It's hard. With 800 volts, you need twice the insulation. You need to keep it safe. You got to manage that voltage. And so,
your creepage
yes,
and clearance.
there are advantages. You do get the faster charging, but you have to put cost into the vehicle in order to manage that 800 volts. And so it's just not the no-brainer that I think some people originally thought it was. And so we're seeing that the amount of cost you have to put in to manage the 800 volts is approaching the same cost level as what we had with 400 volts. And there's a really mature now industry selling components at 400 volts. And so this was the same story we had in the auto industry when we were trying to go from 12 volts to 42 volts or 48 volts.
48 volts, yep.
That there's this installed base of commodity products at 12 volts that wasn't going anywhere. And so to remake that whole industrial base at a different voltage ended up being too big of an investment. And so the 12 volt industry didn't go away.
Yeah. I mean, everything had to change, right? I mean, all the motors ran 12 volts. Now I had to remanufacture it for 48 volts, and it just created a nightmare.
Everything has to be retooled.
Yeah, everything's
from
retooled.
a factory standpoint.
But you said fast charging. So is there a degradation of the battery when you fast charge it all the time? Or doesn't really affect the battery?
Well, people around this table might have different opinions, and that's okay. Batteries are like people. They like to sit in an environment like this. They don't like to be charged too fast. They like to be charged slow, actually. But lithium plating, lithium plating can occur. I guess what it boils down to is if you're going to fast charge your car, you don't really want to do it a lot. You kind of probably want to do it only when you're in a hurry at a charging station and you have to get on with your journey. Typically, they recommend level 2 charging. That's kind of like what the battery prefers overall throughout its entire length. Again, fast charging only occasionally. That's my opinion, and that's actually what I've read from different articles.
The test results, though, so we have 10 years of electric vehicles on the road, and the test results don't show a real significant degradation in vehicle life and battery life. So the original testing in labs suggested that there would be a faster degradation. Lab tests tend to be worst case scenario. And when you go out in the field and you see people actually using electric vehicles, we don't see a huge difference in battery life between people who exclusively fast charge and people who exclusively charge on level 2 chargers. So we're not.
Is it an environmental situation because
it may be
the temperature?
It's got to be a factor.
Yeah, temperatures haven't reached super high, or you might be fast charging on a cooler day versus, like you said, in the lab, it's they crank the temperature up to 45 and fast charge, discharge, fast charge, discharge.
Yep, because you have to do the test in a month and try to get, or 2 months to try to get 10 years of life
Right.
on your battery, and so you set things to the extremes and let her rip. And that's just to make an affordable test that's going to get a result before the product launches. It turns out that test is good for A to B comparisons, but not a perfect representation of how things are actually done and how it's experienced in the field. And now with 10 years of a field experience, we're just not seeing that dramatic a difference. And so for people who own EVs, I would not say that you have to avoid fast charging to protect your battery. That yes, charging to 80% as a habit and not 100% will tend to extend the life of your battery. But choosing to fast charge versus level 2 charging has only a modest benefit.
I think also though, if you fast charge more often than not, you reduce your overall cycle life of the battery pack. And I don't know the number, but I think I've read that somewhere, and I've had people tell me that. In the listening audience, I'm sure we're going to have a whole lot of comments about what we just talked about. And that's good. That's a whole point of this roundtable.
So we're talking about fast charging, and there's an argument that in order for electric vehicles to be commonplace, we got to have fast chargers everywhere. I don't know if that's really true, because a lot of people charge at home, and I can't, in my gas vehicle, fill my gas tank up at home. So is it really important to have these fast chargers everywhere, like in Myers parking lot and wherever? Or is that just something that people believe but they haven't really experienced because there's not enough users out there driving these cars?
I think it's knowledge of the general public, right? Most people think, oh, I can I can fill my gas car up in 5 minutes.
Yes.
I should be able to do the same with the electric car. Yeah. But it's a bit of a mindset change. Like, hey, I'm going to the store.
I can't fill my gas tank up at home, but
Right.
I can plug in overnight and let it charge. So is it really a big deal that I can't charge it when I'm at the grocery store, right?
Yeah. It shouldn't be, because odds are your trip to the grocery store to get home is less than 5 miles.
Well, I haven't had a gas car in a couple of years.
Same.
And I don't miss going to the gas station. In fact, it wasn't until I had an electric vehicle that I realized how much I really hated going to the gas station, because it's every week or so a special trip. I had to go, and stop somewhere and get gas. And I would always end up, putting that off until the tank was like completely empty. And
Well, that's when you put your music down next to the pump, or your window down next to the pump, listen to your music blaring, mess around on your cell phone and stuff like that. Kill the time.
so, but I haven't had any issues going wherever I wanted to go in my electric vehicle. So there has been enough charging stations. Having said that, with the increasing popularity of electric vehicles, so a lot more people have purchased electric vehicles in the past few years.
Right.
So although there are charging station locations where I need them, there at this point now not enough chargers at those locations. And so I have run into the issue on holiday weekends. So driving the Wednesday before Thanksgiving.
Like this weekend.
Yes, this weekend. When you are driving, in this case, I was driving out to Washington, D.C. And so I'm going to the East Coast on Wednesday before Thanksgiving, just like millions of other people. And so when you arrive at gas stations are crowded, But if you have to wait in a line at a gas station, it's going to be 5 minutes, 10 minutes maybe. So I had to wait in line to get a charger, and it was 45 minutes of waiting to get that charger. And so that was less than ideal. And so that we, at this point where the infrastructure is today, yes, I would say we could use some more chargers. But it's not a matter of you can't get where you're going. It's a matter of
Patience.
inconvenience. So,
Patience, yes.
you know, we stop for lunch, charge up, and then we're back on the road. That's the typical. And I have had one case on a holiday weekend where I had to really wait.
Well, we recently did a Monroe live video at 2 locations in North Carolina where we toured 2 different factories that made chargers and different types of chargers. And they're pumping these things out, and there's other companies here pumping those things out. So one day we're going to have a bunch of chargers populating our landscape, so maybe you don't have to wait.
I'm really not
45
worried
minutes.
about it because the business case is there. You know, there are now millions of EV drivers, and they are happy to pay 50 to even 60 cents per kilowatt hour
Yeah.
when they're on the road. And so that's enough of a profit that putting in chargers is profitable.
There's
So,
not only there are companies building chargers, but their customers are like the modified gas station facilities where it's nothing but chargers, and even perhaps, and we did a Munro live video with this particular company out west that they have a grocery store and they have 24-hour security, well lit, and just a bank of chargers, and that's the way things are going. It's pretty cool to be alive now to see this transformation from the gas stations as we know today to something other than a gas station with a bunch of EV chargers.
Yeah, I guess we're gonna have like mixed stations now, right? You'll have your gas side and your electric side.
Yeah.
Kind of like the Buc-ee's or something. With
Yeah,
those
I mean, my
massive
favorite
ones.
is the grocery store because, once a week you need to get groceries. And so you can stop in, plug in, go shopping, come out, and your car is done. You kill 2 birds with 1 stone, and
I've done
good
that
for the
one
week.
before.
Or you can stay home, watch football, charge it in your garage, and have your groceries delivered to you.
Well, let's get back to the subject, actually, because I diverted a little bit. Sorry about that. So let's talk about raw material a little bit. Everybody knows about the lithium and how hard it is to get, right? The bottleneck of the industry. GM did say that they are actually partnering with Novian, I'm sure I pronounced her name, Novian Magnetics, which is a domestic supplier for that, which might help them. But is there any other material that we're not looking at that might be a problem, like graphite or manganese, copper, that might have the same supply chain issue down the road?
Well, I know iron is readily available in this state. We're sitting
Yeah.
in Michigan.
Magnesium.
Magnesium.
But
Manganese.
Manganese, yes, manganese.
Is
Pronounce it right.
it's readily available here in our country too, as well.
And graphite. I mean, there's no.
graphite actually is a little bit of a supply issue right now.
Yeah.
Because it is primarily sourced out of China, and so that's still it's available. I mean, carbon is not exclusive to any one country,
Right.
like neodymium or something like that. Actually, neodymium isn't either, but there are some rare earth materials that are pretty exclusive to China. But yeah, graphite. It just turns out that the processing facilities at the moment are primarily located in China.
Yeah, that's
And
what I was
so-
gonna say. Isn't it just not so much that the
not the
materials
material.
aren't available, it's that the facilities and the production is just not as popular in different locations on the globe.
Yeah, and that was a conscious decision by manufacturers, not just graphite, but all kinds of things, back in the late 90s. We offshored all of that capability to make just about everything to China. Yeah, so it wasn't. We used to have those facilities here. It's not that we can't do it. It's that we chose to do that to send it over there and
Just cheaper labor or
Yes, it was cheaper labor and cheaper facilities that made it.
Didn't have to worry about the emissions that the factories put out making battery cells
Yeah.
or mining.
So this article about GM.
EPA. I think maybe in the next 15 years, right? Once
Certainly
that
long
gets
term.
pulled back, yeah.
And there's been a couple of other significant developments that have gotten a huge boost recently. The threat of restricting heavy rare earth elements has really boosted the development of and the interest in things like Niron, which is a nitrogen iron. It's iron essentially doped with nitrogen, and iron and nitrogen are extremely readily available. The process for making it is challenging, but it ends up with a magnet that has properties, at least in the lab, that are equal to or better than the best neodymium magnets. And so, anyway, that's sort of a progress. If we can make permanent magnets that don't depend on heavy rare earth metals, then that's going to help everyone.
But we are driving some political advantages to bring stuff here domestically. Do you think that may drive a different standard on how we build a battery here in the U.S. versus China because we may do things differently? Or do you think the standards might change?
Well, we literally, some of us sitting around this table did go over there and teach them how to do things and how to do things properly. Those things aren't going to change. What's going to change is trying to mine everything we possibly can that goes into these different chemistries wherever possible within our own country, and then populating either brownfields or greenfields facilities for those that don't exist yet to do so, to build battery cells here of the same quality that the Chinese do today. And they do build good quality product. I might hear some kickback from the comments, but they really do. And we just apply that here, which is what a lot of the companies are doing right now that are in Michigan and outside of Michigan, popping out battery cells.
Going back a little bit to the material collection.
In other words, the standards will be the same.
Yeah.
You
don't think there might be, I'm sorry.
No.
You don't think there might be a different, I mean, we don't know, but looking 5-10 years out, a different way, a different process, something new.
Processes will evolve. Like, for example, moving away from the wet process of coating to the dry process. And not everybody's doing it. Most people are doing the wet process, but that standard will change eventually, predominantly across the board. That standard.
No, it's fine. It's fine. I remember reading a long time ago about like a process where there's these nodules of rare earth metals and metals and things like that on the seabed. I don't know if you guys know anything about that. It was a very interesting article. Basically, over millions of years, these nodules get collected and you can essentially pick them up off the seafloor and then you process it and you have whatever metal you can. But I can't remember exactly, but there was like issues with, marine life and dredging and all that stuff to collect those stones.
There was quite a bit of interest in that off the coast of Japan, that significant deposits were found of heavy rare earth materials. Getting anything off of the deep sea floor
that's
has
a challenge.
Challenges. But these things at this point are so valuable that it becomes worth going after those kinds of challenges. But getting back to the environmental, there's cheap ways to do things, cheap and dirty, where you ignore the environmental consequences, but those consequences eventually catch up with you. When the production volume gets high enough, and that's where we're at right now, where we're making millions of electric vehicles now every year. Once the production volumes get high enough as they are now, then it pays to do things the right way, and you can make money. You know, we've been involved in U.S. plants that are, you know, have union labor, are following EPA processes, and, you know, recycling materials and making profit. If the volume is high enough, you can do that, and that's the transition that we're in right now, which is one of the things that's really exciting to me. That makes the business case doable for a plant in the U.S. or located anywhere, whether it's, you know, Europe, Africa, wherever, that you can do these things in an environmentally responsible way, as long as the production volumes support it.
Yeah, so you capture and scrub the emissions throughout the process of building a battery cell appropriately according to regulation. And I think that's the battery factories, facilities that are here in this country, they couldn't be producing product without following that regulatory standard. And we just need to proliferate that, and we will. Government won't allow them not to do that.
I mean, whether it's government or not, it's the people. You can't make a mess of your own bed. You know, you have to sleep in it, and so it's the people driving the government wherever.
Let me expand on that a little bit, because there's a lot of people who claim that recycling of a battery after the end of life is not environment friendly.
Disagree.
Well,
and why? I mean, that's a saying I hear a lot, right? That
it's not that it's not environmentally friendly. It is. Because it's certainly more environmentally friendly to recycle the battery than it is to dig the stuff out of the ground in the first place.
That's the other argument is making the battery is also a huge environmental impact as well. As so from cradle to grave, is it really a better alternative?
But the issue is that it's at the moment not economically profitable, and that's where, so it may be the environmentally responsible thing to do, but it's at the current volumes that it's not economically feasible. So we're seeing small scale operations getting going, funded by venture capital and grants, but there isn't the profit motive to drive it to larger volumes and scale it. But again, as these materials start proliferating and the volumes in the consumer products proliferate, then the volume picture changes for the recycling industry.
Yeah. And one thing to follow up with that too is when you have a battery pack and it does reach that 80% end of life mark, you could change it into its second life and do the stationary power, or you can go and take out the good cells and potentially put it back into a new pack, or pack that matches the same age. Then when it finally is dead, you can melt it down, grind down all the material, and then you
separate out the black mass.
Separate all the black mass and the metals out.
We're going to be short in time here, but is there a something that we can do better in design to make that easier to recycle, or is that not really?
Well, before recycling, to Matt's point, if you still have life in
reuse,
reuse
first.
Right.
It would be nice to see a handshake between the stationary guys that might not be affiliated from a corporate standpoint with the guys designing the modules or the packs. So the pack leaves the vehicle or wherever it comes from, and it goes to the stationary area. It can be they're taking product that they've already designed for to accept the modules or the cells or whatever it might be.
And actually that circles back to our original comments about going directly cell to pack versus modules, and the flexibility that having modules affords, and having it being serviceable. That at the tail end, the recyclability, and more importantly, the reusability, when you can pull out modules, becomes significantly better. So that's I'm still, even though there is a cost penalty to going to modules before you go to a pack, because then you have extra parts. But paying that cost penalty gives dividends back at the back end when you're doing recycling or reusing.
Very good. I'll ask one quick question, though. A lot of technology is being driven, I think, by the automotive industry in the battery packs. There's a lot more power tools that's used in battery packs and lawnmowers. Do you see any innovation coming from those groups, or are they kind of like stealing from the automotive group and improving their packs?
Probably a give and take. I know there was phase change material in some of the, like Makita and DeWalt battery packs, and Eco, yeah.
And there you're seeing removable battery concepts. Essentially, it's not really even a removable battery. It's a module that is self-contained and removable. And so you're charging in a separate charger. So you have one module, one battery charging while you're using the other. And so that eliminates the slow charging, wait around issue. And that's something that has been played with a little bit. And, NEO has done something that at the automotive scale, but obviously moving something that weighs a ton has challenges. But
I do remember on that point. I remember my past life, right? We were talked about where they'd have a gas stations where the battery would come out. The battery has to be standard now. Every vehicle has to use the same pack, but they slide the battery out and put a new battery in, or they would charge battery up, and
so now
it would move.
That gets into like micro mobility.
Yeah.
Like I think Gogoro, they have in Taiwan, they have a really interesting system.
I think that sounds familiar. Yeah.
But
right. So removable batteries is a significant trend in small transportation and, power tools and lawnmowers and that sort of thing, consumer products. And that's definitely something that we're seeing growing and not going away anytime soon.
Right. All right, gentlemen. Last thoughts before we close it out here?
Well, from my standpoint, I think the host did really well.
Yeah, okay.
So kudos to you.
Thank you.
And thank you, Eric, for producing this. But I think overall, at the end of the day, I think will provide our audience with some good roundtable discussion, and we look forward to hearing your comments. And we hope we can do this more often with different subjects.
Taking the words out of my mouth.
Yeah. Okay,
I'd like to see what
you are the host.
the community thinks too, and do it more.
I mean, that's the
Get their
idea
comments.
is we'll see the comments. Please let us know what you think of this format, like our videos, of course. And if there's any subjects or any topics you would like to see in this discussion, let us know that as well. And hopefully we can continue doing this.
Mm-hmm.
All right, gentlemen. Thank you very much for your
Yeah, thank you.
participation, and we'll see you next time. Thanks.
Take care, everybody.
Bye-bye.